Yeah, this is our example, advanced example. Let's say we are giving this a quadrilateral. It has got four sides, A, B, C, D. You can see the points. A is 4 is to 0, B is 2 is to -3, C is to 0 is to -2, and D is to 2 is to 1 on a Cartesian plane. Now we must prove that ABCD is a parallelogram. How do we prove that ABCD is a parallelogram? We know that the parallelogram, each side, opposite side, must be parallel. Like there must be, this one must be parallel to this one, and this one must be parallel to this one. This is a parallelogram. Another thing, these sides must be equal. This side must be equal to this side, and this side must be equal to this side. Otherwise, it's a twisted rectangle, the parallelogram. How are we going to prove if these sides are equal? Okay, to calculate that, we must use the distance formula. We must calculate the distance for all the sides. Let us start with AB. Distance AB. This one is for A. AB. How do you calculate AB? Here's the distance formula. Root AB will say, start with X. We'll say 2 minus 4 all squared plus -3 minus 0 all squared. That's the answer. And then 2 minus 4 squared is 2 squared, -2 squared. -2 squared plus -3 minus -3 all squared. So this one is 4 plus 9 all squared. What is 4 plus 9? The square root of 13. That's for AD. And then we calculate the for BC, the opposite side. For DC, what is, or we say CD. What is CD? We'll say 2 square root of 2 minus is 2 minus 0 all squared plus 1. It's gonna be plus because it's 1 minus some minus. It's 1 plus 2 all squared. Then the answer is root 2 minus is 2 all squared plus 3 all squared. And then it's 4 plus 9, square root of 13. Okay, so it means these sides are equal. This one is equal to this one. And then you are left with these two. I'm going to calculate, and we'll start with BC. Root BC will say 0 minus 2 squared plus -2, then it's going to be plus 3 all squared. Then here -2 squared is 4. Then -2 plus 3 going to be 1 squared plus 1. Answer is root 5, square root of 5. And then we calculate for AD. Root AD will say 2 minus 4 squared plus, and then we'll say this one is 2 minus 4, then 1 minus 0 all squared. The answer is 2 is -2 squared, and then plus 1 squared. Negative is 4 plus 1. The answer is root 5. So it means this side is equal to this side. They are equal. So we've proven that one. And another thing with a parallelogram, we've proven that these sides are equal, but we haven't proven that are they parallel. How are we going to prove that they are parallel? We are going to calculate their gradients. Gradient of AD, if the gradient, this one is the gradient of CD and the gradient of AB are equal, and then it means they are parallel. And even if this one is parallel to this, the gradient is equal to this one, so it means they are parallel. Okay, let us calculate the gradient of what? Of AB. Gradient of AB. How are we going to calculate that one? We know from YB minus YA. So it means we'll say -3 minus 0 divided by 2 minus 4. And the answer is -3 over -2. And the answer is 3 over 2. +3 over 2. That's the answer, the gradient for AB. And then we calculate the gradient for CD. If they are equal, it means they are parallel. Gradient for CD, we'll say 1, this one is going to be plus 1 plus 2 over, then it's going to be 2 minus 0. 2 minus 0. So this one is 3 divided by 2. They are equal. So it means these are parallel. We are left with this one, if they are parallel or not. Okay, the gradient of okay, we're gonna go to that one. The gradient of what? Gradient of BC. MBC. BC will say -2. This one is gonna be plus 3 over -2 plus 3 divided by 0 minus 2. And the answer is 1 over -2, which is 1 over 2, -1 over 2. That's the gradient for this one. And then we are moving to gradient of AD. What is the gradient of AD? If they are equal, so it means they are parallel. Okay, we'll say gradient of AD is 1 minus 0 over 2 minus 4. And then this one is equal to 1 over -2, which is equal to -2 over 1. They are equal. Therefore, ABCD is a parallelogram. Parallelogram is a palm. So this one is proven. That's the first answer. We first calculated if the sides are equal, the opposite sides are equal. Then we calculated if the opposite sides are parallel. How do we calculate? We use the distance formula to calculate the distance of the sides, and then we calculated the gradient to calculate if they are parallel. And then we are moving to number B, angles of inclination of AB and BC. Where is AB? If you calculate the angle of inclination, remember that you just say tan theta is equal to m, and then we calculate this angle. So it means now we are calculating from AB. Where is the gradient of AB? Gradient of AB towards 3 over 2, +3 over 2. So it means we'll say tan theta is equal to 3 over 2, and then we calculate. We're gonna go and find the calculator. Okay, we went there and get our calculator. We got our calculator now. So now we're going to say theta on second function tan into 3 divided by 2, because it's positive. So the answer is theta is equal to 56,31. Just round off this 31 degrees. Because it's positive, it will be like that. If it was negative, we're going to say plus 180. Because it's positive, gonna be that. If it was negative, going to say plus 180. And then we go, this one is for this M is for AB, angle of inclination of AB. Then the one for BC. For BC, where is BC? BC, what was the gradient? It was -1/2. We'll say tan theta is equal to -1/2. And then angle theta, we'll say second function, tan into -1 divided by 2. Then the answer is -26.57 degrees. Because it's negative, we'll say plus 180 degrees plus 180. And then the answer, theta is equal to 153.43 degrees. That's our answer.